Good morning, geometry students. Don't pretend like you haven't been doing homework in your pajamas. I know you have. It's hard to wake up this morning, the Friday before spring break, so I'm gonna teach you my pajamas, and that's okay. So, welcome. Flipgrid. Go answer it. Go do it. It is good fun. Please do the Flipgrid. If you are here, you're watching this, you've already found the YouTube lesson. Good for you. Please do this problem in your notes, and then unpause it and do it with me. Okay, we are told that segment ST is tangent to circle Q, which means that this is a right angle, and we want to find the radius of circle Q, so we are looking for that guy and that guy. They're the same guy. We're looking for R. You want R. Well, because this is a right triangle, I have my hypotenuse is always C. My other sides are A and B. Doesn't matter which one is A and which one's B. And let's do A squared plus B squared equals C squared. So we have R squared plus 24 squared equals R plus 18 squared. 24 squared was, do not remember what. 576 R squared plus 36 R plus, yeah, I remember 18 squared in my head, plus 324. These R squareds are going to cancel out. Correct 324 from both sides. Those get 50 equal to 30 R divided by 36 on both sides. And you have R equals 7. 7 what? We don't have any units. We were not given any units, so that is all we can say, is R equals 7. Fantastic. Awesome. Also, I am aware that this says never, and yesterday we just talked about how we should limit our nevers, so we're going to take never out of that. So, never do tomorrow what you can do today. Procrastination is the thief. There are times in which, hey, maybe do it tomorrow, don't stress yourself out, take it easy. Like, there are times for that, but if you always tell yourself, I'll do it tomorrow, then that's not helpful, because we should limit our always. Okay, moving on to what we have for today. Today, we move on, section 10.2, which is about finding arc measures, which is why our learning target is I know what arcs are, and our success criteria is that I can find arc measures. So, in order to be able to find them, you need to know what they are. So, let's figure that out right now, shall we? With some vocab. We are going to have quite a bit of vocab today. If we were here in person, I would just print them all out for you, but not here in person. So, if you want to print these out, go for it. Otherwise, that's sound of writing things down. Please write it down. So, the central angle of a circle is any angle formed by two radii. So, this angle right here is the central angle. And a circle can have many central angles. If we had another over here, this would be a central angle. You can have many central angles, but what it means to be a central angle is that the rays that form our angle, or excuse me, the sides that form our angle are radii of the circle. You can see PCQ is a central angle of circle C. Alrighty, next we can talk about minor arcs and we can talk about major arcs. So a minor arc is this red one right here, this guy, and that is just an arc with a measure less than 180 degrees. Think of it like an acute angle less, well, no, don't think of it like that. Never mind. Minor less than 180. Okay, and then we have our major arc. That's this one over here. Major arcs are just arcs with measures greater than 180 degrees. And those should go in your notes, please, and thank you. Next, we have, so we talked about what if they're less than 180 and greater than 180, but what if they're equal to 180? Then you just have half of a circle, which we call a semicircle. So a semicircle is an arc with endpoints that are the endpoints of a diameter. So QR here is a diameter, and that makes QSR a semicircle. Beautiful. Wonderful. And that's how we name arcs, by the way. This right here is how we name arcs. I could say QS if I just wanted to talk about this section right here, I would say QS. If I want to talk about the whole semicircle, I would say QSR. Moving on. I think this is actually our last vocab word. Adjacent arcs. So adjacent angles meant two angles that were right next to each other. So adjacent arcs are arcs of a circle that have exactly 1 point in common. So when we look at AB and BC, they share B. They share that point, these two arcs. So that makes them adjacent. Kind of like, it's kind of like our adjacent angles. They share one of the sides, one of their rays, and that's what makes them adjacent. Adjacent arcs share a point. All right. Okay. Oh, these are technically still vocab words, but we're not going to write them down. No need to write these down. Whoa. Just read and understand. So, measuring arcs. The measure of a minor arc is the measure of the central angle. So, our central angle right here is 50. So the measure of arc AB is also 50. We talk about the measure of arcs in degrees. That might seem weird, but when we talk about arc length, when we talk about the length of an arc, we'll talk about measures other than degrees. But when we talk about the measure of an arc, we are in degrees. Okay, and the measure of a major arc is just 360 minus the related minor arc. So, because there are 360 degrees in a circle, right? If I turn around, we say I've traveled 360 degrees. So, if I take 360 degrees minus 50, I get the measure of the, here, let's do a different color. If I take 360 minus 50, I get the other, what's left over, right out here. And the measure of a semicircle is 180 degrees. The measure of an arc of a semicircle is 180 degrees because that central angle is 180. Okay, fantastic. Wonderful. Moving on to our first example of the day. Finding measures of arcs. Find the measure of each arc of circle P where RT is a diameter. Okay, RT is a diameter. Good to know. If RT is a diameter, that tells us that this is a semicircle. So this is 180 degrees. And now, I can find this measure. Actually, we're going to use a different. I can find this measure by doing 180 plus 110, 360 minus all of that. So this is 70 degrees. Cool, cool. Now let's look at RS. RS is right here. So the measure of RS is 110 degrees. Since this is 110, if this angle is 110, this arc will also be 110. New color. RTS. RTS. You go in the same order as the letters do. So I wouldn't go RTS this way. This is getting messy. But I wouldn't go RTS, oh, this covers all the same letters, R, T, and S. You wouldn't do that. You need to go in the same order. Just like when we name triangles, we call them A, B, C. We go in this order. When I name arcs, and they say R, T, S, I need to go in the same order. R, T, S. So for that, let's see, that is 180 plus 70, or I could do 360 minus 110. Either way, it's gonna work. And that is 250 degrees. Okay, last one, RST. Aha, this is what we were talking about. Now, RST. Now I'm gonna go in this order. RST. And that is 110 plus 70, which is degrees. Degrees. Don't forget your units. Degrees. Alrighty. Perfect. Let's check our work, make sure we were right. 110. Wait, what did we? Oh no, we got 250. Yeah, we got 250. And the last one was 180. Beautiful. We got it right. Okay. Next, important information. We used this in the last example a little bit, but now we're gonna make it ultra super clear. We are gonna put this in our notes. This is the arc addition postulate. Back in chapter 1, we also looked at the segment addition postulate, and in chapter 2, we looked at the angle addition postulate. So, this is a recurring theme, is that if I have two chunks of something, this chunk and this chunk, they add up to equal the whole chunk. And that's what this is saying. AB plus BC is equal to the whole ABC. That's what this is saying. So the measure of an arc formed by two adjacent arcs is the sum of the measure of the two arcs. So two little chunks make up the one big chunk. Okay, last example for today, using the arc addition postulate. Find the measure of each arc. We're gonna color code because I love it. Okay, GE is this arc right here, which means we're gonna look at this central angle, which is 40 equals 40 degrees plus 80 degrees, which is 120 degrees. Beautiful. Now we're gonna look at GEF. So GEF. Oh, so now we're looking at this angle. So we're gonna add up all of these. 40 degrees plus 80 degrees plus 110 degrees. That is equal to 230 degrees. Wonderful. Color coding again. GF. GF is this one, and that is this angle we're going to be looking at. So that's just 360 degrees minus the yellow one, because the yellow one is everything else. So that's just 360 minus 230, which is 130 degrees. Let's stay consistent. We were doing underlining. We should keep underlining. Alrighty. And there you have it. Adding up little chunks to find the total chunk. Sounds good to me. Let's check and make sure we were right. 120 2:30, and 1:30. Boom. Boom, we were correct. Woo! I hope you had as much fun as I did. If you have questions, remember, you should tune in to Mrs. Dodge's live stream from 12 to 2 p.m. every weekday. My internet is working today, so we will have our stream today. Sorry about missing it yesterday. Yes, tune into the live stream. You can also email me, you can comment on this YouTube video, you can do whatever you want to ask questions, as long as you ask them. This looks like a lot of homework questions. It is only 16. But I mean, if you add up like the A, B, C, D, then it's technically 20 questions. But you saw how quickly these went. You're just adding stuff up. You're just subtracting stuff. Simple arithmetic. So don't let that scare you from doing the work. And lastly, your launch for today comes from Audrey Hepburn. She was an actress. And it says, nothing is impossible. The word itself says, I'm possible. So you've probably heard this one before. I especially like this saying because when you say something is impossible, maybe it is. There are some things that are impossible. Surviving in space without a spacesuit is impossible. Living without oxygen is impossible. You know what I mean. There are some things that are impossible. But if you have this mindset of, no, it is possible, no, it is possible, we could find a way, we could find a way, that it shifts your mindset from never gonna happen, I shouldn't even try, to a more explorative, curious, how could we make that? How could we make that happen? And even if you can't make it happen, if you're still thinking about, like, how could we do that? The process of exploring that and thinking about that gives you so much more growth than going, it's not gonna happen. Can't happen, not gonna happen. So, something to think about. I mean, don't go crazy and like, everything is possible. I'm gonna go to space and I'm gonna breathe. Like, no. Okay. Fool it. Use this rationally, but more is possible than you might. So that is my launch for you today. Take it with you as you go throughout your day. Have a wonderful rest of your day, and thanks for being here. Thanks for watching. Bye.